For this example, we're going to use the Greek method for finding the equation of a tangent line to a circle. And we're told a little bit about that method here. It uses the fact that at any point on the circle, the lines containing the center and the tangent line, that would be this line here and its dashed extension, are perpendicular to the tangent line here. Now I grabbed this image from View an Example from the same problem, and I've only updated it here to show our particular point of tangency, which is 1, 2 square root of 2. So the first thing that we're going to do is find the slope of the line from the center, 0, 0, of this circle to the point of tangency, and I could just use rise over run for this to determine slope. So in this case, I would rise 2 square root of 2 units, run 1 unit. So the slope of that line is 2 square root of 2 over 1, or just 2 square root of 2. We know that perpendicular slopes are opposite reciprocals. So let's write the opposite reciprocal of the given slope that we had determined earlier. So now we have that the slope of the tangent line, we're getting closer to what we need because we're asked to write the equation of the tangent line, is -1 over 2 square root of 2. However, we're also told to rationalize all denominators. So I'm going to come down here in this space and rationalize that slope, meaning I'm going to rewrite this value so that there is not a radical in the denominator. So to do so, I have to strategically multiply by some equivalent of 1 that will eliminate this or re-express this denominator so that there is not a radical there. And thinking ahead, if I multiply by square root of 2, square root of 2 times square root of 2 is square root of 4, which is just 2, no square roots involved. But again, it has to be by multiply the entire expression by equivalent of 1, so I also multiply the numerator by that same value. And I get the following. We already said that square root of 2 times square root of 2 was square root of 4, and that's just 2. 2 times 2 would be 4. So this is the rationalize all denominators form of the slope of the tangent line. Up next, now we're going to write the equation of this tangent line. So we have now at this point a slope. This is our slope of the tangent line. I'm just putting sub t there. We have a point on the tangent line. So we could use this point slope form of an equation of a line. So we're going to start with that one. So let's go ahead and input our information that we have. Y minus 2 square root of 2. We just recalculated here, or not recalculated, but expressed our slope. And then in parentheses, we have x minus x sub 1, which would be 1. We'll do a little bit of calculating here because I'm asked to express this in slope-intercept form. If that had not been here, I would stop at this point and type in this answer. But because it's saying express in slope-intercept form, that's y equals mx plus b, let's keep going. So one thing that we need to do is distribute Another thing we need to do is add 2 square root of 2 to both sides. Then we need to combine these two like terms. I'm going to do that by changing this 2 into 8 over 4. That way I see the same denominator. And I'm adding these two fractions together. So in the end, that constant is going to be 9 square root of 2 over 4. And that's what you see here expressed in that slope-intercept form.